So looking back at the same situation, we're looking at the weight of a truck on a scale, static, versus being able to weigh it as it's going down the road. That's a weight in motion. We're now going to talk about how to get the line of best fit using StatCrunch. So what I need to do is come to my stat options, and what we are going to be doing is called regression. And we're looking for a line that's going to be simple linear regression. So my x value is going to be the weight in motion, and my y value is the static weight that we're trying to predict. And let's make sure we got everything I need to. Okay, fitted line plot, that's fine. Okay, so I'm going to compute it at this point. And let's make this a little bit bigger here. Okay, so let's talk about this information here. Let me go ahead and copy and paste this so I can write on this screen here. So this is all the data we have, and let's talk about what we need to know at this point. Okay, so right here is your equation. It's really important that you know how to deal with an equation written in this format. Okay, so there is your equation. Now, there's a couple of different ways I can write this. I can use x and y's if I want to. So if I want to write this in terms of x input and y output, then I could rewrite this equation as y is the static weight, which equals 10.85398 plus 0. Gotta move that over a little bit. 637914444x. There's my equation. The slope is the number in front of x, because remember, it's y equals mx plus b. M does not mean the first number you see. M is the number that I multiply by my input variable x. So there is your slope. Also, if you get confused, it literally tells you this is your slope. B is your y-intercept, but notice they give it first. It is still your y-intercept. So down in the parameter estimates for your slope and intercept, I can just write the equation from this information because it gives me slope and it gives me the intercept. Everything you need to come up with an equation for a line is in the slope and intercept. Now, the correlation of coefficient, going back, what does that tell us? That tells us how accurately do the points come to the equation of the line or the model, and a 0.96 correlation of coefficient is almost 1, which means almost perfect. This is really, really tight model. So we've got a great model. Now let's go back to StatCrunch. We're going to hit page 2, and this is going to show us the actual best fit line. And again, I'm going to go ahead and copy and paste that so I can write on this. Bring it in here just below what we were doing. So again, this matches. I've got my fitted line, or the line of best fit from my linear regression. And again, this can be done with a graphing calculator as well. So from here, using what I know about my line, the equation of this line, I'm just going to round it to 3 significant figures for this particular example, and using y as the static weight and x as my weight in motion, then the equation would be y equals the slope, and again, 3 significant figures. That's going to be, I'm going to round that 7 to an 8 because the number behind it is bigger than 5. So 638. X plus my y-intercept, and again, I'm going to go to 3 figures. 1, 2, 3. I've got an 8, but behind it is a 5, so I'm going to round up to 10.9. And that is the equation of the line written to 3 significant figures. Or if I wanted to round it to the thousands place, I could as well for everything, but then I would have to round my intercept. And again, all depends on the instructions. So if I go there, then it would be 8, what is it? 3, 8, 5, 4. So there's rounded to the 10,000s place. Okay, so really the big thing here is to be able to interpret the information that the computer is generating for you. And again, the computer figured out where to place this line of best fit by minimizing the residuals squared when added together.